I'll open up a chat session again. Live share. Heat helped this morning a bit, but it wasn't great. I did sort of alternating hot and cold this morning for a little while. Okay, so where we were at is we were writing tests combined with the exercise, yeah. Sometimes shit just hurts. I mean, not much getting around it. All right, so we are writing tests because what we want to do, quick overview of what I want to do today, if possible. Let me get the right windows up here. Oh my gosh. Okay. So in this application, we're not even doing encoding numbers. We're going to actually create a real spatial pooler in simple HTML. And we're going to use it for these visualizations here. Not this one. This is just about encoding, but this one, potential pools, and this one, the permanences. We're going to use a spatial pooler instance to populate those instead of just the data structures we're currently using. And we're going to do that in this simple HTML right here. Simple HTML. That's the code base that I'm going to be working in today first. So if you'd like to follow along, this is where we're at. So let me check out a brand, spatial pooling, and I'm going to add the algorithm here, tests. So I added these two new tests offline a little. Well, I wasn't offline. I just wasn't officially doing building HTML systems. But I just added this test, and I added a spatial pooler. So now we have a spatial pooler tests, and we have a spatial pooler class. The spatial pooler class is empty. And I have tests. The tests say spatial pooler instantiation when creating potential pools with 100% connectivity. Let's put percent in here. With 100% connectivity, each mini column is fully connected to the input space and contains potential for pool indices. That's what we're gonna get running first, and then we'll come down. Then we'll make sure this works. I think this will just work. But so first of all, the first failure that we get if you do test-driven development, you just run the tests and fix the failures. And it's that we need a potential pools function. And there's no, I'm manually failing this one because it's not implemented. But first we'll fix this one. So we're going to create get potential pools function. Now, if you remember, I don't know if you remember or not, but the way I do test-driven development is stupid. But not stupid. It's you write the simplest code. I know some people hate this, but you write the simplest code to get the test to pass. I enjoy working like this. Yeah, I'm going to build my own basic SP, and if I run into trouble, we'll go look at Paul Lamb's spatial pooler implementation for inspiration. That sounds good. Okay. So the easiest thing to do to make this pass would be, and this is stupid easy, is the potential pools should return a list, and each one of those things is another list. So a list of lists, and each list basically a list of indices. So I guess we should let's actually store some things from the constructor. Let's say we're sending in options. Come on, okay. So what I'm getting is input count, size, and connected percent. And so I can create exactly what we want here using that. So get and like I said, I'm not going to take a ton of shortcuts. The outside video feed is blocking the code.
I'm sorry, Dave. I'm afraid I can't do that.
Thank you. Yeah, it is kind of blocking the code, isn't it? We could do this. I like my outside video feed. Or we could I could just move it a little. Click right, move it over. There we go. So, the code we're going to write here is not going to be pretty. This is going to pass the test. That's the idea. So when we call get potential pools, we're expecting it to have the length that's the same as the size that we sent in. Okay, so we can use that. Let's say let pools equal new array this dot ops dot size. So that'll pass that test, I think. Right? Now, so let's do this like sort of step at a time. I just want to see that tests are passing. This is a very incremental approach to programming, but I tend to make the least amount of mistakes when I do it this way. Let's see if this test passed. Okay, so that test passed because we're just passing an array of the right size. Now, if I change this +1, I also would like to see this fail, but it doesn't, so something's wrong because we're not returning anything, so it shouldn't even pass. Yeah, scroll down. I can't even scroll down. I'll fix it. See, I didn't. Oh, I know what I'll do. I'll split it down. There we go. There we go. So this isn't even, it's like my test isn't even working because I'm asserting a size. Why doesn't this work? I mean, this should fail because this isn't returning anything, all right? Get potential pools is not returning anything with each mini column. So am I not, it's probably because I'm not in scalar encoder, spatial pooler instantiation, there it is. Creates a potential pool for each mini column. Each mini column is fully connected. See, these are just because I commented them out. And contains potential pool indices. I know what it is. It's because this it shouldn't be within this other it. And I've since moved it. Anyway, so that's fine. Okay, so now it should fail because we're not even returning potential pools. Yeah, pools is undefined. Okay, so we return pools. Right, so now this test should pass. Well, no, it won't. New array, if I do this, it should pass. Potential pools, return pools. Right, I need to set this. I'm going to do this here. Okay, we'll deal with that later. It contains potential pool indices. It doesn't really matter the connectivity here. We'll restructure this, I'm sure. But I just want to see this test pass, and then there we go. And now we should watch it fail if I add like 1 to it. Good, just want to make sure that I'm testing the right thing. Yeah, I'm checking the tools for sure. All right. Okay, so yeah, 201 is not the same as 200, so that is working. So now I need to expand my test, and we'll do that by saying for each pool, let's assert the length is correct. So this is going to fail because these don't have links. They're nothing. It should fail, but it doesn't. Oh, for each pools. Oh, that's because the for each doesn't work. Because this is has an undefined amount of things. David, you pointed me into this. You pointed me to this last time. So instead of dealing with this, I'm just going to actually create. I'm just going to create what I want here. What I want is first. I'm going to do this very explicitly, like I said. This dot ops dot size, because this is going to be for each mini column for each. I'm going to call this mini column index. For each mini column. Oops. All right. For each mini column, we're going to say pools dot append add. I always forget push, and we're going to send it. Size. We're going to send it an array. Now we should have a test that fails. That's the idea. I'm hoping this fails. Okay, good. Oh, but not for the reason I thought it would. Size. Oh yeah. You were trying to point that out. It's not for each. It's times. Essentially, what I'm looking for is times. And we did this by doing this silly array thing, right? Dot array, this dot ops dot size, right? Wasn't it something like this for each? Or was it new? So I've already forgotten how we were even doing this because it doesn't make any sense. There should be a much better way. Like Lodash has times, which is exactly what I want. But I'm close here, right? I'm close. Here you can see David, the code elf, coming in to fix things. Thank you for doing that for me. Why doesn't this work? Am I doing something wrong here? Sorry, Discord, yeah. I have myself muted here. Let me put my headphones back on so. Oh, all right. David, can you hear me?
Yeah, can you hear me?
I can hear you. Can you guys hear David? I think I can actually hear some echo in Twitch. Hopefully there's no echo now that I put my headphones on. Oh, I can fix that, sorry. Now there's no echo. Okay. So, what's going on here? Isn't this the way we had done it earlier? This for each deal?
Yeah, it should be.
Doesn't like it. It IDE.
What version of JavaScript is this using?
Hopefully the same version as the other. Okay, hold on. I'm going to think of the JavaScript project configuration. Oh, this is not part of a JavaScript project. CommonJS, ES 2016. I guess that's, I don't know where this even came from. Apparently there is a JS config file somewhere. VS Code, launch. All right, I saved it. Maybe that will fix it. But that should not affect my runtime. I mean, I'm running with, I'm not running through, I'm running node 11.7. Okay, there's got to be a better way to do this. Well, so, like I said, I'm just going to do it a simple way. And we'll say, I wish there was like a range, like Python's got nice range functions.
Why don't you just pull in Lodash?
No, I'm not going to pull in a third-party library for this. X equal. When's the last time you did this? I know it'll work. Okay, pools.
It's actually faster than
Yeah.
using like for each and everything.
Okay. Not x plus plus. Count plus plus. Okay, so that now I'm hoping we'll get like a legitimate failure. Yeah. Okay. Yeah. So that's the failure I wanted to get, which is this should be the size of the input, not the SP. This should be the size of the SP. This should be the length of the input. So, and it's saying expected that to have a length of 200, contains potential pool indices. That's not even the one that I expected. See, I'm doing it wrong. This is silly. What am I doing? This shouldn't be count. I'm like screwing everything up here. Hold on. This dot ops dot size. So this is every mini column. For each mini column, we're going to push this, and we're not there yet. So this should give me a different error. Yeah, pool is not defined. Pool is pool. P. This is P. So now we should get this assertion failure. It says 100 and it's actually 0. All right, finally we get to the point where we have the right failure. And so at this point, we want to, now we're gonna have one pool. This is a pool for a specific mini column, and that's what we're going to turn back. And now we're gonna do the same thing, essentially, for, let's use I and J, because that's like the quintessential count numbers you always do for 2D array movement. J less than this dot ops dot input count. Is that what I called it? Input count. Yeah. J plus plus and pool push. So here's the tricky bit. First of all, I'm just going to push I. I'm just going to push, and let's just push this. I know that's not right, but it'll pass the test. That means we have to write better tests. Okay, so that's certainly not what we want to do. Now we have to actually look through and make sure that each index, so this is 100% connected, so every index should match. So now this is going to fail because I doesn't equal 0. But now I'm going to do this wrong first, and because if I put a J here, that's not. No, that is what I want. If I put an I here, it should fail. Actually, I think both of them will work. No, they won't. Is J gonna work? J is the one that works. Okay. Okay, so this is not gonna work for everything. All right, so we have a passing test here where we're getting a potential pool with 100% connectivity. So let's do one with less than 100% connectivity. And for tests, I do not mind a little replication. In fact, I think it's almost better to have some replication of test code, because then you can go straight to one test and understand the whole thing. Okay, so let's get rid of this one. Each mini comes fully connected. Okay. So with 50% connectivity, this is going to be tricky because it's like random, so semi-random. We don't know which indexes are going to be included and which aren't, because for each one it's a 50% chance. So there may be, I mean, there should be should be a distribution around 50% of those values. So first of all, let's see. Let me see. How should we test this? We don't know exactly. We don't want to be exact, but we know there should be around 50% indexes. So for each, let's see, length of this input count. So first of all, let's watch it fail, because it will fail. It won't fail. That's because I need to create a new spatial pooler with a different count. So if I'm gonna do this, I'm gonna put my SP here inside the test I'm describing. Again, so the input count, connected percent now it's gonna be 50. So for each one of these columns, we should be connected to about 50 input bits. I don't know what the error is going to be, but I think what I'm going to assert on is that there's somewhere, first of all, that every index is within the range. Okay, here's a couple of things that I'll assert on. Contains pool indices. Okay, I'm having some ideas now. All indices are within range of input space. Okay, and we're going to do one that says no repeating input space indices, something like that. So those are two tests we'll need to write. Okay, so contains potential pool indices. So we're not going to do this anymore. So for each one of these pools, we're going to I kind of want to I'm not gonna, so for each one of these pools now, I want to do basically these two checks. Perhaps it's not going to work if I do it this way, but these are basically the things I'm going to be checking. So for the pool, I need to go through all the indices and make sure pool dot for each, and we'll call this pool index. Okay, one is that I can just make this a comment. All indices are within the range of the input. So that's one check we'll do, and then no repeating input spaces, that we'll do after. We'll do that down here. It's easier to do outside the loop. So all this is assert. Basically, I'm not familiar with the assertions. Is at least, no, at most. The pool index, I just have to make sure is not bigger than the input space. Is below this dot, oh wait. Whatever the input count is, yeah, input count. Okay. So I think this should pass. Oops. I think this will just pass. No, the argument to below must be a number. Oh yeah. Input count is below. So it's pool index below input count. That's what it should be. Okay, so that is what I expected. Now, if we program this to return some crazy count, like this should fail more than one test, but it should definitely fail the one we just wrote. There should be two. Yeah. Contains potential pool indices. I've got both of them here.
There's a dot close to assertion too, like dot close to, and you can give it.
Oh, great. So I'll use that when we're doing the fuzzy thing. But for this is going to be exact. And what I'll do is, I think there's a way, can't you give any of these pool index out of input range? I think you should be able to specify that and it'll give you an error message. Yeah, pull index out of input range. Perfect. Okay, so that's the error I wanted to get. Now if I take this off, the other error, what did it say? Expected 0 to be 1, so let's try and fix that one. So this is length of, so yeah, so this error is pool count is, oh no, that's in a different one. That's in the 100%. Okay. So this should say, whoops, for say fully connected layer should, I hate saying fully connected layer. Fully connected pool should be same size as input space. Okay, so I don't want to see those errors. That one's not even the one that's tripping. Which assertion is tripping here? Expected 1 to be equal to 0. So it must be this one. So this is testing how, oh yeah, so this is the wrong one. Well, this should be the one that goes in here. Oh boy. Right, because this is the one I'm actually checking the size of the pool. This one is checking how many pools there should be, or how, potential pools. This should always be the same size as the mini columns. Pools should be same size as column count. Okay, where's this assertion? 3. So this is what I hate about this. It's not, I don't know the line number.
It doesn't tell you at where the top of the error is.
I don't see it. I mean, it says 6,
Right.
6 to 8, but that's not right. I think it's compressing it or something. But it's definitely test 1, spatial pool instantiation, 100% connectivity, contains potential pool indices. 100% connectivity contains potential pool indices. It's gotta be this one, the only one that I haven't asserted, or haven't given a description for. And what am I doing here? Should be the same size as input space. Certain length of the pool, okay. Am I doing this? Oh, this is just checking the index, right. And so I'll say each pool index should match input space index. Just call it like that. I just want to see, there we go, each pool index should match. So now at least I know, I have a better idea of what's failing. And that's only failing because I did this. So now everything should work again. Okay, and I've got my better test failure descriptions. And I'm going to add the same thing here, assert length. And I'm going to have to change this, I think. No, that's fine, that's right. That's always true. Pools should always be the same as the mini column count. But it's this one that's going to be different. These are going to be different because we have 50% connection. So this is the only one I'm going to do inside. Okay, so for each, it should be the same size. For each, all indices are within the range of the input space. Did I not do this one? I should have done this one up here. Yeah. This has nothing to do with the 50% connectivity, so why don't I do it here? Oops. For each. I got this wrong. No, this is right. Input index, pool index. Yeah.
That's just because it's 100% connection rate, so you'll have every single
Yep.
input.
And I should also, I don't need to do this here because I'm basically checking every one. So I'm not going to check every one like this, but I am going to, so I did have this in the right place, but I am going to check. I'm going to have to do the same thing here for each, and get the end. No, I don't need the pool. This is fine. For each pool index, make sure it's below the input count. Okay, so that should work. I think I might have already run this. Okay. And then we do this part outside of the loop. Oh no, I already did that. So this would be the, is like close to, cert, is it close to? So I'm assuming we're going to say the p.length is close to input size divided by 2, or times the connected percent or something. Input count times, let's say, connected percent. That way we can change it later. Connected percent times 0. So we're gonna move the decimal point. So I don't know how.
I think that's an argument of close to. You could tell like a delta to make sure it's within a range.
Okay, let me look it up.
So I'll put a link in the Twitter.
Like I can Google it faster. There it is. Actual expected delta message. Okay. Actual expected delta message. Okay. So we will do actual p.length expected is, well, input count. Well, that's exactly what I was doing. Input count. I'm expecting it to be whatever the connected percent is. You know what? Let's make this a decimal to make things simpler in the long run. It's gonna break things, but no, it won't break anything yet. So then we can just say connected percent here. We won't have to. And then, so the delta is also, so I'm gonna make the delta, shoot, I don't know. It's something, input count, 10%? I don't know. Input count times 0.1. Let's see what happens. Let's see what happens. It's not going to work, right? Because I haven't actually set it up. Connected percent is not defined. That's easy enough. That's going to be 0.5. I didn't pull it out, so let me pull it out. Expected 100 to be close to 50. Right, so it's getting a fully connected. I think that's reasonable. Go 10%. So that's a legitimate failure. We expected 100 to be close to 50, but it certainly is not. Okay, so now we have to do something. Legitimately do something like real coding. Because this is a stupid function. It's always fully connected. So we're only going to push this under a condition. And we'll say if math.random greater than this.ops.connected percent. Then we'll push. Percent. So I don't want to do that, David. I want to keep this really, really explicit. So even if maybe we'll come back and refactor later, but especially during the construction of all of this logic, I want to be really explicit. And I think this is pretty explicit. So this is exactly why we would create the potential pool if we're above the connected percent randomly. So I'm going to run this.
Oh, you want a less than sign there, right? Or no?
Less than, yeah, you're probably right. Yeah. That would make a difference, wouldn't it? Expected 61. Oh, this is interesting. We're getting quite a bit of deviation then. 60, it's always 61. That's not right. 62. Okay, so something's certainly wrong. Why would that? Actually, I'll just do this. I want to make sure I'm seeing the right thing here. 1 point. Okay, so that's right. Math.random is. How is this happening? This is freaking me out. Now it's 38. Maybe it is. That was weird because I had 60 something 3 times in a row, and now it's down. Wow. I just expected it to be like closer to 50. Okay, I got an idea. Let's just increase the size of all these counts so we can have a bigger like sampling space. So let's just add 100. I don't need to add 100 to that. So let's multiply this by 100 for the input count. We should get more reasonable numbers. Yeah. Okay. So I think I just needed to increase the number of samples I was doing to get something closer, which makes sense because it was deviating too much. Fewer samples. That's why sample size is important. Just an example of it. But this is still going to fail occasionally, which sucks. I mean, if I ran this enough, it will eventually fail. So it's not the best. The bigger I make it, though, as long as it doesn't take too long. That takes a long time. That takes way too long. Timeout. So we're not going to do 10,000. We'll just do 1,000. Okay. Like I said, we're not going to think much about optimization or anything for the time being. We're just going to make the functional tests and make them work. Okay. So where we were at is we've got a different connectivity. I am also we could turn this into a test that goes through several different connectivities and tests it. Probably wouldn't be a bad idea. Let's do the repeating input test. So basically, this is a. Is there a same equal? So I'm just gonna take a. I'm gonna take. Sorry. The P. Are we in the pool? Close to. Yeah. So for this pool, isn't there a unique function? And I know there's ECMAScript unique array.
No. There's an includes, but that's not going to tell you if it's a unique. I could
have swore there was a way I've done this. It might have been Python. I think this is super easy in Python.
You can do a filter. You could filter, and then check the length of the filter.
Is set a top level object in JavaScript now?
Yeah.
Well, I'll just do that. That's easy. So the idea being, so that's basically unique. So right. If I say new set and give it the p and pick that length, that should be equal to p.length. That's testing whether uniqueness. Pool contains more than contains non-unique indices. Okay. This is probably going to pass, but I'd like to see it fail too. So let's. Oh, it doesn't. Expected undefined to equal 502. What did I do wrong here? Set might not have a length. It's probably something else.
Maybe size or something.
Yeah. Set class. Let's just say length. Its size. I should have done. And is it a function or a property? It is.
It's a property.
Or I could have just run the test and known. Okay, so that passed. Now let's make it fail to make sure that we're actually testing something. Okay, so what I'm gonna do, this is gonna fail more than one thing, but I want it to fail the right thing. So I'm gonna push. This is a little crazy. Math random as less than 10% of the time we'll add something twice. And so this should fail several tests, I would hope. Yeah, pool contains non-unique indices, that's the one, and the length test, because it's got way too many things in it. So that's good. That's good. All right. So let's not do that. And watch it pass, and all is good. Okay. All right. So just to sum up where we're at, we've got spatial pooler when creating potential pools with 100% connectivity, contains all the pool indices. Contains potential pool indices. Pools should be the same size midi column count. Fully connected pools should be the same size input space. Each pool index should match input space index. Now let's do this. So ideally, we should be able to do something like this. So let's say const connected percent test cases, and we'll say 0.10. Let's just do 0.25, 0.5, 0.75, and then 100. This should work for all of them. And so now I'm just going to loop over this. You see what I'm going to do? I'm going to basically take this test and I'm going to loop it and do this test for every one of these so that we can verify, some type of spectrum. It should work exactly the same for each one of these. So connected percent test cases for each target connected percent. And now I can pop all of this down, I think, into this loop. Okay, and then this doesn't exist. And connected percent is going to equal target connected percent. And this should work. This should work. I wonder, okay, this will be great. Hold on. I got an idea. I should be able to add another describe here. Describe with, and then specifically say with, what is it, target connected percent connectivity. I hope this works. It should work. So now I can put all of this inside this describe, and then in our test readout, we'll get a full description of every single one that we tested, I hope. There we go, 25, 50, 75, 1. Perfect. Okay, so we are testing. I mean, this takes a while, but I don't mind. Falco says the quotes and the describe are different. Quotes in the describe. Oh,
Yeah.
these are
A string
a string template. Yeah, that's so I can do this substitution here. Okay, so this is good. This is good. What else do we need to test? So I mean, we're writing way more code or test code than we are real code, which is good, which is what we should be doing. So we've got the case with 100% connectivity, we've got the case with less, and then we go through all of those cases. We've got this is sort of a special case, but because we're going to specifically check every index is included, and all of these we're just checking that it is close to 10%. And you know, we could, if we wanted this to run less time, we could increase our wiggle room here, right? So let's change this to tolerance. Let's say test tolerance. I'm gonna put this up top here. Equals, I'm gonna make it 0.2. How close should the be to expected connectivity? So we're gonna put 20%, we're using the input count of 100. So I bet this will pass, and if I put it back down to 1, it might not. I think one of them, yeah, they all passed. And then it ran a lot faster. Oh, it's like increasing in speed, so I've got a memory leak somewhere. Or increasing in size. But maybe in the test. It's probably in the test. So if I put this down to 1, it might fail. Yeah, it does fail. So let's find a happy middle here. I want to get close. That's still failing. Yeah, it's just too random. Let's make this like 200. At least let's double it. That might be enough. Of course, you want your test to be idempotent, of course. Or is it stochastic? I don't remember. I'm gonna leave this for now. If there is a chance that it might fail occasionally. Okay, so... Okay, what are we missing here? I think this is perfectly fine, as a matter of fact. I think as far as potential pools goes, this is probably fine. So one thing, oh, okay, so I know it, something we need to do, and this is an API thing. When we create the spatial pooler, the potential pools should already be created. We want to make sure, there's another test, here's another test, this is a good one. We want to, it doesn't matter the connectivity, triple first mini column. I think I'm not gonna do this. Okay. Get potential pools are always the same. Alright, so this should be easy. It doesn't matter which. Now I'm gonna use one with less connectivity, because that will, because if they're 100%, they will always be the same. But let's say potential pools, let's call it less than fully connected. Be very explicit. Are always the same. So this is gonna fail, I'm certain. So we're gonna do this again. We're gonna make this 0.5. Doesn't really. That's 0.85. Doesn't really matter. And then we are going to say pool 1 equal sp get potential pool const pool 2 sp get potential pools assert. I know there's like a deep equal. not deep equal pool 1, pool 2. They should never. They should. Oh, I'm sorry. Equal. Not. They should always be equal. Initial pools were. Is it what word am I looking for? Stochastic or idempotent? When you call this function, it always return you the same thing. I think it's idempotent. Let's just say they should always be the same. Okay, 2 pools, they should be the same. Let's watch this fail. That's not a failure, that's an error. What did I do? Oh, it's a search error. It's just cannot read children of undefined. It's in the middle of the test. I think it failed. I expected to. I'm not getting a good test report out of this though. I mean, here's the error. Expected one array to deeply equal another array. So I guess that's okay. That's definitely the problem. Okay, so the way to fix this is. So I'm gonna change this function. I'm gonna call it. I'm gonna make it an underscore function. I'm gonna say create potential pools, and then I'm gonna say this dot potential pools. And again, I don't know what the way to do this, but this is the way I always do it because JavaScript's so loosey-goosey. If there's a way to truly make a private member, that's great, but otherwise I'm gonna do this. So I'm going to create the potential pools once. Why can't I call this? Oh, equals. And so now I need to add this function get potential pools. Return this dot potential pools. There we go. All right, so this will ensure that upon initialization, we create the potential pools, and they are never recreated. Idempotent, denoting an element of a set which is unchanged in value and multiplied or otherwise operated on by itself. That's the mathematical explanation. I think when it's used in a programmatic term, it's like if you have especially in the service-oriented architecture side of software, if you have a service, someone calls it and it's idempotent, it means it's not accumulating anything. It's going to return you the same thing every time you call it. It's not retaining a state and deciding to do something different if you call it at a later time. It's always going to do the exact same thing, which I think is the right way. I want to make this get potential pools essentially an idempotent function. Okay, so it's like
now why do you put the underscore before it? Is that like the term of private member variable?
Yeah, that's the only thing. I'm just trying to denote that if anybody's looking at this code, they shouldn't call this from outside. If there's a better like ECMAScripts way to do this.
You could declare it as like a private.
Okay, how do I declare it as a private?
Just word private now, I think.
Like this? But is it still a this? Or do I do it up here? Whoops. Let me try cool X. Private, potential, cool, like that. I didn't know there was a private keyword in JavaScript. Script 6, oh, let's see. New private class fields and how to use them. Headers and setters. Oh, okay, I can do this. I'll do a setter and getter, that'd be good. Stop. But there's no private class. Oh, I see. So if I don't declare anything, can say that is. Okay, let me try this. Let's do this. Let's say we're only getting, because you can only get potential pools. And then
I think you could use a hashtag to declare this private.
Wait, the hashtag? Oh, got it. That thing. Oh, that's weird. So that's static and private. Okay, so hashtag something. I can do that within. Oh, so then I say this dot. Okay, so hash potential pools. First, they're going to be undefined. It doesn't like that. Do I need the constructor now?
That's like a future. Yes.
Yes, next.
Stuff.
Okay, well, I'm not going to do that then. I'm just going to do it the way I'm doing it. We can come back and make it better later. For right now, let's just make the tests run. And they do. Okay, so 100% connectivity, less connectivity, less than fully connected, and then we just did the make sure that they're always the same. Less than fully connected, potential pools are always the same. Creates an initial permanence value for each cell and potential pool of each. Yeah, so we haven't done this, so we could start doing. Does anyone think of anything else that we should test? We're not testing right now. As far as potential pools. I think we're about covered it. We're going through a bunch of connectivity range here. All right, so let's move on to, okay, when creating potential pools. So now we need to describe when establishing initial permanences. Okay, this will go inside here. Okay, so we're gonna repeat some code here. We're gonna, again, I'll just use a fully connected one because we're done, essentially, we're done yeah, we're done testing the potential pool. We do need to assert that however we get the permanences matches the potential pool somehow. It's like the size of the permanences. Like if I ask for the potential pools, it's going to give me an array of indices to an input space for each mini column. If I ask for the permanences, it's going to give me an array for each mini column of arrays, which is weights. Okay, so it's really similar to potential pool, but instead of an index, I'm going to get a weight back. And so I think we're going to do a lot of the same, but I'm not, yeah, a lot of the same testing here. I think we might be able to like take this almost exactly and just change from looking at the indices to looking at the actual weights. Let's do this. Let's create a new one here. Okay, so again, with 100% connectivity, let's start with that. Contains potential pool indices. Contains any column permanences. And we'll just say perms should be the same size as a mini column count. That's still true. Fully connected pool should be same size as the input space. That's also true. These aren't going to be pools anymore. This is going to be, we'll call them perms. And we're going to say get permanences. Okay, so perms should be the same size mini column count for each one. Fully connected perms should be the same size as the input space. And then now we're getting, so this is not an input index. This is a permanence. Yeah. This is the tricky bit because it's not linked to the index here. It's linked to the pool, and you have to get the pool to get the input index this permanence is associated with. So now we need to decide what exactly do we want this this to look like. It's almost like permanences, or excuse me, potential pools is a subset of what you want to do when you get the permanences. But you have to establish the potential pool before you can populate the permanences. We can probably do them all at once. Okay, just from a testing standpoint though, when I call get permanences, I am expecting one per mini column, and each array per mini column is just a list of scalar values that are associated with the same indices that are coming from the potential pools. So what I'm actually going to do here, I'm going to get pools too. Perms and pools. And now for each, let's call this perm, now that we've got both. Perm, and for each permanent, and now for each permanence, we can look in and get the input index by going to the pools. Okay, now I have to go here, hold on. For each perm, any column index, go to the pools at the mini column index, pool index. Okay, this should be the input index. This is not, this is actually true. This should still, could move this up one if we want to test it. That should still work. And then we'll actually call, yeah, each pool index should max the input space index. Only for fully connected. And so then our input index, I guess all we need to test, well, we need to test that there's not duplicates. Okay, so again, input indices. So I've got my input index. I'm going to add it to the input indices that I have seen before. Input index. Okay, and at the end, maybe I should put this here. So for each permanence, yes. So put it here. And that will, so for each permanence I have a different, yeah, different input index. And then we're going to do, bye Mark Brown, thank you. Ibuprofen's kicking in a little bit. Oh, it feels a little better. So we should have at this point a list of indices which should be the same length as the input, because each should be represented exactly once. So we can do this. We're already doing this here, so I know this is going to be right. Let's push. And what I want to do is know that there's every one of these, there should be the same amount at this point. Okay, assert, so here's our first assertion, equal. There should be the same amount of perms length as input indices length, since we're 100% connected. Fully connected perms should same length as input space. Okay, let's see if that passes. I'm hoping I'm thinking correctly here. All right, can I read? this is again unexpected end of input. 37. Oh, that actually gave me a, so I've got a syntax error somewhere, hold on. Where's my syntax error? It's probably something to do with all these nested functions. Did I just forget to do something like this? Probably. Maybe not. Where am I? Oh yeah. So get potential pools is not a function. No, get permanences is not a function. Why is it telling me that? Oh, that's because I changed. I was gonna change it to a setter, didn't I? Okay, I'm gonna set this back because I don't want to change it right now. There we go. Get permanences is not a function. That's the one. So now we have to write the permanences get permanences function. Okay, so I'm gonna do the same thing basically that I did before. And I'm gonna see, the thing is, if you call get permanences from step to step, they will change. So I can't write the same test assertion, because as learning occurs, they'll change. If no learning is occurring, they won't change. I don't know if I want to test that right now, but I'll definitely add get permanences here. And we'll just make the test pass so far. So give me a more relevant function. Perm should be the same size as mini column count. Okay, so let's basically, I'm gonna steal this and we're gonna go through and do something super similar. Perms. Now I'm running into some term issues. One mini column perms. Okay, hold on. Let's change this to total. Oh, let's call it all perms, and we'll call this one perm. For like perms for this mini column's permanence. Get all permanences for the size. Count. And so now we're not. Actually, this is stupid. This is not what I want to do. I have to get the potential pools. Get my potential pools. And then basically I need to go, I want it to match exactly the potential pools. Because if I did it this other way, they might not match. So I've already done the calculation. I basically established a potential pool for each one of them. I have to create this value. So create potential pools, get potential pools. Okay. So all perms equals that. So for pools, for each pool, and I don't think I need the index. I don't need this index, right? I do need, now for the pool, now I need this index. This is going to be input index and pool index. Oh my gosh. Okay. What did I do wrong here? I have too many pools. Oh. Thank you. I got this. Okay. So I'm using my pools, and now I'm going to create my perms. So this is going to be a perms for this. Ugh. And for each one of these, I'm going to push a value. And for right now, we'll just say math.random. And then we'll just test that it's there. And then we should be able to return pools, not pools, all perms. Okay, and here we say all perms.push, and we send in the perms. So each mini column is getting an array of perms, which we're looping through the pools. We don't need this pool index. We don't need any of this stuff. All we need, we don't even need this. Does this even work? Can I do that? Can I do this?
No, I can't do that.
I don't
you
even
can do that.
Yeah, so I don't need anything like that. Okay, so now we're just gonna get a random pool. So let's see if I should have written a test for this probably before I wrote the code, but I wasn't quite sure what I was gonna do. So we're doing this, but I'm not actually getting the permanence. Perms are same size. Each pool index should match. So I should check that the permanence value is a number between 0 and 1. I can do that here. Assert. Is there a between? Is between. Okay, I'm gonna go look because I probably should there's one. Chai JS number between. All this number is an integer. So this is where I've done this before. Fail. There's no between. Less than. There's definitely less than. So I could say is below, is at least. I could say is below and is above. I could just do that. Okay, so is below permanence. But actually what I want is less than or equal to. Is at most. Let's say that. Is at most. Permanence is at most 1. Okay. I'm gonna say permanence value cannot be larger than 1. And we'll do the same thing, is at least 0. Permanence value cannot be smaller than 0. How long am I going to stream? I don't know. I don't know. I need to take a lunch break, but I brought a sandwich, so I'd like to try and get some of this hooked up into the diagrams. So another couple hours probably, if I can. Okay, let's see what tests happens now. Input index is not defined. Input index. Right. I don't have an input index. I've got set many column index. Each pool index should match input space index. Oh, let me think this. Something's wrong. Input indices. For each permanence should be the potential pool index.
Are you declaring input index for you, sir?
Yeah, no, it should be right there. I think that's it. Alright, fully connected perm should be the same length as input space. Fully connected perm should be the same. So this one's failing because my perms are 200 and they should be 100. I think I just hard-coded a comparison. No, I didn't. The perms should be not the input indices. We're inside, so for one mini column, its permanences length should be the size of the input array. I've already asserted the other length. Let me do length of. Should be length of perms. Should be, what did I call it? Input count. Not sure. I don't think that's gonna make it pass, but it's a better. So, okay, so why isn't this working? I'll actually figure it out. This is a valid failing test. So it's something the way I'm doing this. So I get the pools. For each pool, I create a permanence. So this pool is one mini column. I create a list of permanences for each. I've already, this pool should go through every input space. For each one, I push a random one. Aha. No, that's right. This here. This is where we're failing here. This is at the top level. No, it's not. This is. I think this should be called perm. No, wait. Perm. This is a permanence. This is the actual value. Okay, hold on a sec. Okay, I'm gonna change some names. I think I have some naming confusion here. I'm gonna call this all perms. Okay, I'm gonna call this perms. Okay, this is like one mini columns permanences. So I'm asserting the wrong perms here. So this should be perms, not all perms. I'm already doing the all perms comparison here. This I'm making sure that the individual mini columns permanences are mapped to the input. They should have the same amount as the input. I think that's right. Just had some naming issues. Okay, good. All right. So, and this seems to be working. So what happens if, let's make this fail. Let's add 1 to all of our numbers and we should get a failure on the upper bound. Yeah, can't be larger than 1. So that's what we expected. Okay, so we are not checking the distribution of the permanences yet. Right now they're completely random. And if you remember the way I created the permanences last time, it needs to be in some type of distribution around a center point. At least that's what we do in NuPic. Before I get to that, let's write a note and commit some changes, and then I'm going to take a lunch break. I think I'm doing this well enough. And we'll probably come back and do this. Whatever test we come up with here, maybe we'll come back and do a version of it for less connectivity. You know, basically the same thing we did with potential pools, and hopefully be able to just copy and paste a lot of stuff. So it contains mini column permanences, and I need to ensure that mini column permanences permanences are normally distributed around a center point. So this will be the tricky bit here. We'll come back and do this. Implemented. One failure. Okay. A lot of changes. Okay, I don't need this. I'll delete that file. I don't know why that's there. I've got category tests. I removed that. That's fine. I was just cleaning up. So spatial pooler tests is all new stuff. Spatial pooler is all new. We don't have a lot of code in here yet, which is good. Okay, let's do them all. Okay, initial SP tests for potential pools and perms. I meant to do them all. Speed test for pools and perms. Okay, we'll have 2 commits, oh well. Okay. Git push origins spatial pooling. So that should be out there. I haven't merged it yet. We're gonna do a release. Once we get this branch fixed up, we'll do a release on simple HTML, and then we'll go to building HTML systems, and how did that happen? Yeah, then we'll go to building HTML systems and require the latest version of the release and put this in place. But first we need to get that potential permanence thing. One thing before I go, because we're gonna have to look at this soon enough, is that Bates distribution that I used in building HTML systems, and where were we on that? The potential pools and permanences. Here's the permanences. So remember we did this the other day, and we had, right, render permanences. Where was the Bates? There was something with Bates. I thought this was it. There it is, Bates, random Bates. Set up initial connection strings. This is the bit we did. So we're gonna be pulling this out and using it somehow in spatial pooling. I don't know if I want to write my own random Bates thing or use D3s. I don't know. I'm trying to create simple HTML with as few dependencies as possible. But we're gonna basically do this inside the spatial pooler when we're doing this permanences, so that we get them distributed properly. So we'll do that next. For right now, I'm gonna take a break. Do some more stretches, eat some lunch. Feel free to chat. I'm gonna take my headphones off so I can hear you even if I'm walking around the room. You guys want to see the guitar I've got coming? I'm so excited about this. There it is. I pushed it to a branch, David, called spatial pooling. You should be able to see it on my fork. I just wanted to show you my guitar. I don't have it yet. Eventually. Soon. I should have it by Friday. Look how pretty that is. I've been waiting for a long time to get this, to get a nice electric guitar, and my saxophone finally sold. And it's shipped already. Holy crap. I love Sweetwater. If you're ever into anything AV, music stuff, sweetwater.com. It is ready to be picked up by the UPS. That's so exciting. Needing space approval. The chat status is, hey, I think maybe it's back. Hey, look at that. Okay, so I guess I don't need this thing anymore. That was weird. That's a lot better. I don't like the other chat. I still have no idea what was wrong. Just magically fixed itself, so. Works for me. Welcome back, chat room. I'm taking a quick break, and we are building HTM systems. We're doing spatial pooling right now. We're just creating the initialization for a spatial pooler. And we're not even using D3.js or React today. Yet, or might use D3 a bit later. We're just hooking up the actual initialization functionality into a spatial pooler class, and in our simple HTM project, and then we'll integrate it into our diagrams. Alright, I want to try and get this done. So I wonder how hard it is to implement a random Bates function. Random Bates. Bates distribution. The mean of a number of statistically independent, uniformly distributed random variables in the interval. Excuse me. Continuous probability distribution of the mean of n independent, uniformly distributed random variables on the unit interval. This is defining the probability density. Oh, you know what I'll do? I'll just look at D3. I'll look at the source code for D3 and see exactly how they do it. Right, random Bates. So I bet this goes right to the code, right? Oh, so it's going somewhere else. Irwin Hall. Oh my gosh. Okay, let's see. Irwin Hall. Random Irwin Hall. Irwin Hall. Source random interval, Irwin Hall. So that's the thing. This is it. Sum from 0, sum of 0, I is 0, I is less than n. To the n times plus 1, sum equal to the source. Source is the function we're sending in. So, let me just export. This is exporting and calling. So we take a source. Go back even further here. When we call random Bates, we give it n, which is the number, what I'm calling a connection distribution. Yeah, or spread. I think, yeah, I'd maybe call it a spread.
What does that do exactly?
So this is, the n is how many independent variables, this is a math thing. So it's this, we're doing this bit. We're calculating a random Bates distribution. Every time you change this, 25 is the n, or 20. The thing I'm changing right now. That's n, or what they call it is independent variables. How many independent variables there are. So I want to sort of just convert this code. So I'm going to send it in, which we are doing here. We're already sending it in, which I'm calling spread. And then there's something else that's outside of this. So all we're sending into this is n. So I want to basically take this function out. I could just use D3, I mean, honestly. But I'm trying to prevent going into other libraries for things. So, just because I want it to be really clear what's happening in the simple HTML code base. So so I could just like steal this, you know, and why do we need default source? What is that? I'm confused by default source. Oh, that's just a random. That's weird. Default source is a random number. I don't know why. So
that function gets called when it's exported. It's like wrapped.
So it's just needs a, and it generates a function. Because the API is, this returns a function that basically runs your random baits for generating numbers and independent variables. So I could take this probably and just put it in my utilities. But I want to understand what it's doing
like
too.
A seed, right?
What?
Is that like a seed?
It seems like it. Seems like a seed, yeah. Because this Irwin Hall thing also takes a source. And here's the n. Like, here's the function you're actually calling with the n when you call it, I think. And it returns the function. This is what does it. So what do I have to go through this hoop like we're jumping twice through here? What is going on in here that's not going on in there? It's calling it and dividing by n. Random Irwin Hall. It's so weird. So maybe I will. I mean, there's one easy way to do this. I think. Let me check my. Let me check and see if I'm using D3 anywhere. I might already be using D3 in this code base. If I am, I mean, I might as well continue using it. Bounded category. I think I actually did use it for some of the scales. Scalar. Yeah, I am. Okay, so let's just use it. Let's just use it. And then we won't worry about. We'll just say we're using the random baits distribution. And that's what we'll do. So, but I still need this bit. So we'll take this. This is the main code that we're going to need to make this work. Of course, I want to write a test, so let's just park this for a moment. Let's just park this right here and start writing a little bit of a test. So how am I going to test this? So here's where we're testing. Fully connected potential poles are the same. Let's get down to the permanences. Contains many column permanences. Okay, so okay, one thing I could do to test this is the average of all of the connection weights should be the center of the should be 0.5 essentially, the center of the distribution. That's going to be the correct. That should be correct no matter what. Unless I start twiddling with the center of that distribution, of course. But as long as I'm not doing that, the average should be a half. You know, halfway between 0 and 1. I think that's true. Yeah. Okay, permanences are normally distributed around a center point. So now we need to do some of this again. I'll take some of this and copy paste. So I'm going to get my permanences and get my pools, not that assertion, for all perms. Mini column index. I don't need to keep track of this anymore. I don't need to do that. 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 Okay, all I need to do is test that each mini column's average of all their permanences should be close to 0.5. Unless I specifically tell it not to be. Like, I should be able to change that average easily by moving the center of the distribution. Whatever amount I move the center of distribution, I should add to that 0.5, and that should be the new average. So the center point, I'm going to put by default. And that's going to be 0.5 by default. Okay, so now I've got all my perms I don't need this anymore. All I need to do is say perms dot okay, so now I'm gonna look at ECMAScript again. Oh. JavaScript array average. Is there an easy way to do this?
No.
No. Dang it. There should be. Damn it. There should be. Okay.
I'm sure D3 has like an average.
Yeah. Yeah, you're right. D3 array. Do I have to create a D3 array? They might call it mean. They do. D3 mean. Mean. Alright, let's try that then. I gotta go grab it. Okay, where were we? D3 dot mean of my perms. Okay, assert is close, or was it close to? Okay, so this should be, I'm shooting for 0.5. That's the average, and we're gonna give it plus or minus 0.01. I guess 0.1. Average permanence across mini column should be centered at by default. So this is gonna work, I think, because I mean we were doing math.random, which should have the same property. Whoops. 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 So I think this should work. Yeah. I wonder how close we can get. Let's go 5% delta. Yeah, so it's a little iffy. So that does work. At least we know that works. But that doesn't really test certainly doesn't test that we have a normal distribution. So now what we can do to test there's a normal distribution is we can sort the permanences and then assert that the midpoint is, after we've done the sort, we should go through them and find where we hit 0.5, and it should be very early on after we're sorting. Well, that depends on what we would call the spread or the independent variables. So first of all, let's set up a random Bates with independent variables being 1, which should be basically math.random, and this test should still pass, and as we set up the random Bates, it should continue to pass. Okay. So let's put the random Bates in place now. Alright, so our Bates function we will create when we initialize. I'll just say this dot Bates function. D3 random Bates, and this is connection distribution. I don't have a parameter for this yet. This is what I really want to do. Connection distribution. I guess I'll call it connection distribution, but this is really not a good name. It's the number of independent variables for the Bates calculation, but low is really spread out. High is like super peaked. So somewhere between like 0 and 30 is what I've typically been seeing here. Let's call it Bates. Let's call it exactly what it is. Independent variables. Okay? Or 1. For now. for now. So if I send it 1, and then I put in place the, if I don't send it anything, and I put in place this, now I can use my Bates function. I have to have a center. Okay, again, distribution center. Let's set this. This dot Bates center equals this dot ops dot Bates center or 0.5, because we want it to be the center of the weights by default. I reserve the right to change all this stuff. I just want to see the functionality working and the test passing. Okay, so I have a center, and then essentially for each mini column, we're going to get, so I don't have to do this anymore, this connected percent thing, because they're all connected. The ones that I'm going through are already connected. All I'm doing is calling Bates function plus a center. I've already got the center, so I'm not gonna do the center yet. I'm not gonna do the center yet. So all we have to do is, instead of math.random, we just call this dot Bates function. Okay, I mean, that worked. It's essentially random because, and even if we change the distribution, it should still work until we start moving the center point. So now, so if it's completely random, there should be essentially the same amount of numbers in like the first 10% of the range as the middle 10% of the range. If it's not random, you're gonna have a bump, you know. So we want to get to the point where we have a bump. When we call it with no independent variable and it uses 1, let's look at this again. Let's be explicit about what we're doing here. So if we make this 1, not 181, just 1, that's the random spread. If we make this 2, it's already not random. So there should be a difference between 1 and 2, and certainly a difference between 1 and 20. Okay, and 0 is just flat 0.5. All right, so how to test this? So if I use 1, it should be essentially random. If I use 2, there needs to be a distribution. So I need to check. So here's what I could do. Around the center point, let's assuming its default is 0.5. I should be able to take an average and make sure that that's larger than an average near the on either side of it. Okay, so does that sound like a reasonable test, just to ensure that there is a normal distribution or some distribution going on that's centered around a center point? Hi Falco, welcome back. I think that's what I'm gonna try. I'm gonna take, so let's go back to the test. This will all be happening within the test. All permanences are normally distributed around a center point, default. Okay. So this isn't actually a good name of the test. Permanences are normally distributed. No, let's say randomly distributed by default. Because that's really what we're doing here. We're randomly distributing them by default. And so let's assert that as we go through, let's go through like 10%, 10%, 10%. Let's window through this, take an average, and make sure that they're all very similar. I think that's the right thing to do here. And then, I mean, I could just grab like the first 10%, the middle 10%, and the last 10%, and ensure that the average of them are essentially the same. I don't mind being very explicit about this like that. I don't need these pools anymore. So let's try that. Let's call this first 10%, and we're gonna say perms 0 to perms math.floor perms.length divided by 10. Okay. Oh, no, wait. What am I doing? Perm. I don't need that. Math.floor. I'm just trying to get a slice, and I'm not doing it right. Hold on. Perms.slice. Okay. 0 to. There we go. 0 to whatever that is. The length divided by 10. So the first 10%. Const last 10%. Basically, same thing except backwards. Perms.length minus that 10% up to perms.length. Actually, I think I can just do this, right? Yeah, I think. It's not splice, it's slice. Slice from 0 to something, or from some length to the end. Right, I think, yeah. Slice. Okay.
Yeah, slice will give me a copy of the array.
Right. That's perfect. Okay, and then I'm gonna do the middle. Middle 10% equals slice, and then perms.length divided by 2. This doesn't have to be perfect. Okay, starting at this divided by 2. Hold on. Before I do this, let me. Before I finish this thought, sample width is going to be 10% of the perms length. So math.floor perms.length divided by, let's say times 0.1. Okay, so there's our sample width. So I don't have to use this anymore. Now I can say sample width. Okay, so that's clearer now. Minus the sample width. So we're gonna slice from the sample width onward, back from the length, right? So the last 10. And so this one will be, get rid of this, starting at, let's call it mid index equals perms.length divided by 2. So then we're gonna slice from the mid index minus okay, math.floor sample width divided by 2 comma mid index plus math. Actually, let's pull it out. I could just call it half width, because why not? Or call it half sample. Okay.
You don't need to sort this, right?
I do. I will soon. Thanks for the reminder. Okay. Just gotta get some of the minutia of these calculations out of the way. So yes, I do want to sort them. Sorry, I'm just thinking. I want to... There's no topology. Wait a minute. Now I'm a little confused. I may have just confused myself here. How did I do this? How did I make this histogram? I'm having a brain fart. I need to go look and see how I made this histogram because I've forgotten how I ordered it. Draw histogram. The data is mini column, selected mini column. All right. For each mini column, I'm creating another, size of the input space. If it's connected, plus the this is hard to do without looking at distribution center. It's hard to do without visualizing it, honestly. Update distribution center. I think when I called this, I'm just manually telling it, 0.5. So this is only 0.5. No, okay. Yeah, the random baits will give you a distribution centered on 0.5 by default. Yeah.
So the point of that is what? To be what your connection threshold would be? Is that what the center is?
Well, that line is, the red line is the connection threshold. It's independent from the Bates distribution. We can have it wherever we want. Or wait a minute, here's the line. This is the line. So when you change the connection threshold, it sort of operates on top of the permanences. So you can have that threshold wherever you want. That's beside the point. When we talk about activating mini columns, that's going to be important. But all I keep thinking is each mini column. My brain needs to think for a minute because I'm confusing myself. This histogram is a count. I keep forgetting, like, the histogram's got, yeah. I think I'm doing this wrong. I'm thinking wrong in this test. I'm not doing this right. I definitely need to sort. Okay. Yeah. So I definitely need to sort. If I sort and there's a normal distribution, definitely the first 10 is going to be way different than the last 10 and the middle 10. So I think that's what I need to test. So I think I'm sort of on the right track. But I got to remember that the histogram is a representation of the permanences. They are not the permanences. It's a count of the permanences that fit into the right bins. Okay. So I'm close. I think I'm close. Half sample, mid index. Yeah, slice. Okay, so let's sort this first. Let's say sorted perms. Sort copies the array, right? I hope.
Yeah.
So I should be able to boom. Oh, that doesn't matter. Slice. I better use the same thing. Okay. Okay. So, these should all, by default, without creating, without specifically identifying the number of independent variables for the base distribution, these should all be basically averaged the same. They should all be pretty much the same. So, assert close to. So when I say d3.mean first 10%, oh, it isn't. It didn't copy. Okay, thanks. This should be close to d3.mean last 10% by a factor of 0.1, I guess. Let's see if that path even runs. Okay. So it's not. Okay, great. So they're totally different. Totally different. Oh, I guess this would always happen, wouldn't it? Because even if you have a random distribution, I mean, if you sort them, of course the high values are going to be way different than the low values.
Right.
Before sort, we have to do this before sorting them. So this shouldn't be done on the sort. This should be done on just the any.
Yeah, I think you're right. I think you want to remove the sort.
I want to remove the sort, but I'm not sure I'm actually testing something I want to be testing. If I have a random distribution. Oh, wait a minute. Okay, hold on. Okay, I just had a thought. We go back to this. So we take this back to random. And then if I change this, oh, it does break. It's not exactly what I wanted. It moves the entire distribution, which isn't what I wanted. I don't know. I think I need to think on this. If I specify that I want the permanences initially 85% connected and no, 85% potential pool, that's different. Each one of those permanences then I want to most likely be, yeah, okay, so here's the thing. I want them to be, if I give it an independent variables of like 20, then most of those should be around 0.5. That's the thing. That's what okay, so if they're all random and I sort them, it should be a straight line. Okay, so this is where I'm getting to. I'm gonna draw. Let me draw here. Okay. So if everything is random, and I plot them all, and I sort them, it should be like basically. I mean, there's going to be a lot of wiggle room here, but they should be sorted from, 1 to. Well, actually, it's going to go the other direction, right? It depends on how I sort, but it's going to go like this. Up to 0, but basically a linear plot. This is if independent vars is 1. Now, if it's not, if I give it a different independent vars, because I want a normal distribution, if I give it, for example, 20, then this is out the window. And what I should see, whoops, is is 0.5. I should see, wait a minute. Yeah, so this is just a distribution. Sorted by weight. It's gonna go up. You know, I think I'm gonna bow out today. I'm really distracted by this neck pain, and I don't feel like I'm being very efficient right now. Because I'm stuck on something I shouldn't be stuck on. This isn't something I should be stuck on, and I'm starting to think it's probably because I'm having a hard time focusing. So I hope you guys don't mind if I come back on another day and try and finish this up. There's only 3 people watching anyway. So. So I think I'm gonna do that. Sorry, David. I think I'm gonna shut the stream down. I'm gonna think a little bit on this offline. I'm gonna go to the chiropractor, and I'll be back. Then I'll be back online. Probably, definitely Thursday or Friday. Then we'll finish this out. At least the permanences, potential pools, and put them into the diagram. Because I think we're pretty close. It's just I'm having a hard time sealing the deal right now. And like I said, I think it's because I'm distracted by physical pain. All right, so see you guys later. If you don't mind, I'm gonna take off and lay down or something. Appreciate it. Thanks for watching. I'll see you guys later. I'm gonna close the thing. Oh, here's my credits. I think I had a couple follows. There. Be rousing and fixable. Thanks for following.
Are you committing that to your branch or no?
Yeah, I will. It's just it's not in a good state, but I'll go ahead and push it
Yeah,
so you can play with it.
We'll have a go.
Whoops. All right, see you guys later.